Okay, this is like building blocks of getting to the unit circle, and this is building block number 1. Actually, it's probably not even 1. It's probably step 3 or so. But we're not there yet, and we won't be there yet. We'll get there tomorrow. Is when we'll have the full picture yet. So today is angles on the unit circle. So we've kind of done this. So this should be mostly review. So it should go quick. We'll see. A unit circle is a circle of radius 1 centered at the origin. So it's like the 1 unit circle is one way to phrase it, but nobody calls it that. But it's called the unit circle because the unit is 1. The radius is 1. We'll note some angles on the unit circle that correspond to the special angles of the special right triangles that you learned in geometry. 30, 60, 90, and 45, 45, 90. And in fact, while we're here, because we'll have time to do it, let's put the patterns on there. Do you remember the patterns for 30, 60, 90?
X.
Where does X go? You're right. The short side. Okay. There's a root 2 in there somewhere, but that's not on this triangle. That's on this triangle.
X squared is side 1.
Not X squared.
It's X cubed.
Not X cubed. Definitely not. 2X on the hypotenuse. And then across from 60, X root 3. We'll use these tomorrow more, but we may as well see them today. 45, so short side still X. Short sides. And then X squared root of 2. And then a bunch of those values will show up on the unit circle because sines and cosines are ratios. But for now, the key angles are 30 and 60 and 45. And so let's write the measures in degrees and radians for all the 45 degree markers. So let's do the degrees first because that's easy. 45 degrees, 90 degrees, 135 degrees, 180 degrees. I guess we should start at 0. 225, 270, 315. And 360. Okay, well, that hopefully was pretty easy. Just count by 45. You might not have memorized that 45 is pi over 4, but you definitely know that 180 is equal to pi. That's kind of where I would start. So I know that over here is pi, and then I kind of just start backing up. So halfway is pi over 2. Half of that's pi over 4. And then, let's see, halfway between, didn't we do this already? Halfway between a half and 1 is 3/4. So 3 pi over 4. And halfway between, oops, let's do these. Halfway between pi and 2 pi is 3 pi over 2. And then halfway between 1 and 1 1/2. Is 1 1/4, but as a fraction, 5 pi over 4. And then on the other side, halfway between 1 1/2 and 2 is 7 pi over 4. Or you just count by pi over 4, right? 1 over 4, 2 over 4, 3 over 4, 4 over 4, 5 over 4, 6 over 4, 7 over 4, 8 over 4. I guess absolute worst case scenario is you do 315 times pi over 180. That's really not the best way to go, but that would get you 7 pi over 4. That would be like absolute last resort if you got stuck. you could convert one by one. But that would take way too long. Please don't use that method. But if you get stuck for one, you could do that. Okay, so there's our over 4s. We said this before, but all the over 4s are the middle angles. All the over 4s are the middle angles. Maybe that's dumb and pointless today, but it'll be helpful tomorrow. All right, turn the page, and there's a typo on one of these next two pages because they both say 60 degree equals pi over 3. I'm like, well, yes, it does, but let's do 30 degrees equals pi over 6. So 30 degrees. In fact, let's do all the reference angles that are 30 degrees. Let's do it that way. So all the angles that are 30 degrees from the x-axis. So first quadrant's easy, that's 30 degrees. What's 30 degrees from the x-axis in the second quadrant?
150.
And 30 degrees from the x-axis in the third quadrant? 210. And 30 degrees from the x-axis in the fourth quadrant? 330. Okay, 30 degrees is pi over 6, so that one's easy. But what's this one? How did you get 5 pi over 6? That's right, but how did you know that?
Because you can multiply it by pi over 180.
Okay, so that's one way to do it. 150 times pi over 180 is 5 pi over 6. Anybody get there a different way?
Just count by line.
Okay, count by over 6s, like pi over 6, 2 over 6, 3 over 6, 4 over 6, 5 over 6. Is that what you were going to say, Michael? Okay.
Just do pi minus 1.
You can also do pi minus pi over 6. So you're pi over 6 away from pi, so 5 pi over 6. So it's helpful to, you don't have to use all of those, but it's helpful to at least see all of those and understand all of those, because Dia, what you did was right, but I don't want you to do that every single time for every angle, because that would take a while. There's quicker ways to get there. All right, how about the 210? 7 pi over 6. Not by converting, but by either adding pi over 6 more or by counting our way around. And how about this last one over here? 11 pi over 6. Our over 6s are all the shallow angles. The over 6s are all the shallow angles. Turn the page. Wasting all kinds of paper today, but that's all right. 60 degrees is the pi over 3. So let's talk about reference angles of 60 degrees. Well, what's 60 degree reference angle in the second quadrant? 120. And reference angle 60 in the third quadrant would be whatever 180 plus 60 is, 240. And then reference angle 60 in the fourth quadrant is 60 from 360, so 300. And then kind of that same process of how do I figure out what 120 is in radians? Well, I could do times pi over 180. How did you get that it's 2 pi over 3? Okay, there's a couple ways to get there, like the direct conversion method. 120 times pi over 180 is 2 pi over 3. Not the best way to go. You could count. If you double from Oh, careful, that 2 pi over 3 is on this one. It'll get confusing there. If you double 60 to get to 120, then you double pi over 3 to get to 2 pi over 3. You could use the reference angle idea that it's pi over 3 away from pi. So 2 pi over 3 would be where you're at. How about in the third quadrant? If you're pi over 3 away from pi, you're at 4 pi over 3. Or you're counting, or you're converting. You can count, you can convert, or you can reference angle. What's pi over 3 shy of 2 pi? 5 pi over 3. And then if we zoom out, like literally zoom out, we can see that the pi over 3 reference angles are all these steep angles. Put it all together. Okay. Let's go in order. I'm going to go in the same order. Let's put the quadrant markers on first. 0, pi, 2 pi. Halfway is pi over 2. In fact, we're going to only do it in radians because we're basically slowly transitioning to all radians here. No need to keep it a secret from you. So halfway between pi and 2 pi is 3 pi over 2. And then if I remember the shallow, middle, steep thing, all of the shallow angles are over 6. All of the shallow angles are over 6. All of the shallow angles are over 6. So the first one's pi over 6. That's the easy one. This one over here is 1/6 away from pi, so that's 5 pi over 6. 1/6 more than pi is 7 pi over 6. 1/6 less than 2 pi would be 11 pi over 6. I think we did this once already, but let's do it again. All my over 6s are the shallow angles. So if you got 3 colors of highlighters, that's great. If not, no big deal. Share with a neighbor. I've got a yellow and a blue and a pink I'd love to throw at someone if they would like to borrow one. Anyone else? Depending on how much I like you determines whether you get an underhand toss or an overhand fastball. Got it.
You can get an overhand fastball.
No comment. Let's see, that was the shallow angles. Let's do the middle angles. All the middle angles are over 4. So pi over 4. And then in the second quadrant, 1/4 shy of 1 is 3 pi over 4. And in the third quadrant, pi over 4 past pi is 5 pi over 4. And in the fourth quadrant, 1/4 shy of 2 would be 7 pi over 4. And then pick another color and highlight all of those the same.
Are we leaving it over the points?
Not today. Not today. You're really slowing it down. Let's focus only on the angles today. But we will add the points tomorrow. Let's see. That leaves the steep angles, which are all over 3. So first quadrant is pi over 3. Second quadrant is pi over 3 shy of 1, so 2 pi over 3. Pi over 3 past 1 is 4 pi over 3. And And then pi over 3 shy of 2 pi would be 5 pi over 3. And then pick one more favorite color. And even before we put the points on, there's already more patterns there than, like we've made note of a bunch of them, and you guys have noticed a bunch of them. But compare the numerator to the denominator in quadrant 2 and quadrant 3 for that matter. I don't find this helpful, but some students do. Yeah, the numerator is 1 less than the denominator in quadrant 2. In quadrant 3, it's 1 more than the denominator. I don't know. I don't like that. I like to think reference angles. Pi over 6 is the shallow. Anything over 6 is the shallow angle. Anything over 4 is the middle angle. And anything over 3 is the steep angle. To me, that'll see you through calculus if you can remember that much. Well, a little bit more, but shallow, middle, and steep. Okay. That's kind of it for today. Today's assignment is worksheet 5. And it's all about locating angles. So no sines or cosines yet. Just where are these things located, and do you shallow, middle, and steep, that sort of thing. Number 1, let's do a couple together. We'll just kind of jump around a little bit. So grab the worksheet packet. Indicate each angle on the unit circle. So 60 degrees. This is just kind of eyeballing. So 60 degrees is about right there. So I'm just going to label that A. 280. What quadrant does 280 land in? How much into the 4th quadrant is it? Not much. That's a good answer. So angle B is not much into the 4th quadrant. C is negative 225, so be careful, we're going backwards with that one. So what quadrant will I land in if I rotate backwards 225? Okay, if I rotate forward 225, I land in quadrant 3. But I need to rotate backward that same amount, so I would land in the middle of quadrant 2. Because it's not like I'm not landing at 225, I'm rotating backwards 225, more than halfway around. And then 10 degrees, that should be an easy one, just a narrow angle there in the 1st quadrant. Why don't you try 2 and 3? Number C, negative pi over 4. So be careful. That doesn't mean go backwards until you get to pi over 4. Pi over 4 is a measure of how wide the opening is. So I need to go backwards pi over 4. So that would land me in the, almost said the 1st negative quadrant. That's a terrible way to phrase that. It lands me in the 4th quadrant. They're still numbered the right way. But because I'm going backwards half a quadrant, maybe phrase it that way. 7 pi over 6, so that's a little more than pi. Over 6 is a shallow angle, so 3rd quadrant, shallow angle. Okay with those? Good with those? I feel like this is easy. I hate to ever say that about a lesson, but it's just super important before what we get to tomorrow. So I don't mind. Sure. Oh. Yes. Why is it like pi over 4? Or how is it like? What's that?
It's 10
That's exactly right. It's like, not like, it is 2 pi plus pi over 4. So you go all the way around and then pi over 4 more, and so you still land in the first quadrant. Coterminal is the fancy name for 9 pi over 4 and pi over 4. So are they alike? Yes. Are they identical? No, but they have the same landing spot. Okay, I think the rest is fairly straightforward. You can do some conversions, you can draw the picture, you can, however you want to do it. Make sure you get to number 12, because that's the lead-in for tomorrow. And again, I don't think today's too hard. I hate to say that, but